Okay, good afternoon, everyone. Welcome to Slot Finite and Infinite and Done. My name is Ryan Bales. We're here to talk about Jupyter Notebooks. And I totally get that I am literally the last person standing between you and a really cool movie, so we're going to get through this together. It's going to be fine. So let's dive in. So I'm Ryan. I am not from Columbus. I live, work, and play in Cleveland. My company is based in Chicago. I go there quite often. Browns fan. If you're in Columbus and also a Browns fan, okay, cool. All right. Should be a good year with OBJ, hopefully. I've had enough years of not good, so fingers are crossed. So I work at a marketing analytics company called Dialogue Tech. We focus on helping marketers gather insights from their phone calls. My team primarily works on our post-call actions, transcribing your call from the recording. We run a lot of machine learning models on top of it to gather different insights, locate keywords, locate trends, sentiment, all those things. I also work with a company based out of Akron called Drive IT. We do some Python and data science instruction, kind of after work evening classes for folks in the field. So why are we here? My main goal in this talk is to show to all of you that you don't always need a desktop-based, full whiz-bang IDE to be productive and to write good code. If you're doing certain job functions like prototyping, if you're in the data science field and you're trying to explore data, or maybe you're trying to hook up to some APIs and see if you can pull that data into your platform, this tool is super easy to get started with and can be portable and easy to share your results with your team. So in this talk, we're going to dig deeper into what is JupyterLab, how can I get it, what can I do with it, and then we're going to talk about some cloud-based options for those that don't want to run locally and run on their local machines. So what is Project Jupyter? It's a nonprofit group focused on open and interactive computing. They have released all of their software under a modified BSD license. And their main goal is to provide open standards across as many programming languages as possible. It was born out of the IPython project. That is the predecessor to Jupyter around 2014. And primarily they're focused on the data science and research communities. That's actually where I found them. In the analytics space, working with a lot of data, you see a lot of tools like this that are being used to explore that data. I found this stat super interesting. There are 3.3 million public Jupyter Notebooks on GitHub. And that's interesting for two reasons. Number one, that's actually about 4 or 5 months old, so it's probably who knows what by now. But that's public. I personally do a lot of private ones in my company. That number is probably infinitely more than that. But it's a tool that has taken hold and has found a really good use case in a lot of different things outside of data science. So what's in the name? So Jupyter kind of stands for the 3 core languages that are supported by it. First is Julia, Python, and R. And this is another cool little fun fact. Jupyter was named and spelled this way kind of as a homage to Galileo and his notebooks he used to record some of his early discoveries and findings when he was exploring. So let's talk about different Jupyter applications. First came Jupyter Notebooks. Jupyter Notebooks is still really great. It's a great tool. I highly recommend using it. But then they came out with, recently, a V2, like a new next generation kind of tool called JupyterLab. And it's a more modular extension-based platform that some of the gripes about notebooks have been solved and made better inside of JupyterLab. And we'll get into some of those in a minute here. Also important to note, in the family of Jupyter applications that are available, there's a tool called JupyterHub. And we're going to keep JupyterHub out of scope for this conversation, but if you have a team and you want to spin up servers in your colo or in your office or whatever the case may be, maybe in AWS, you can install JupyterHub, and that is a way for you to manage packages and secure access to to a full team and share the same common platform with everyone. You don't have 6 people on a team setting up different instances and version 2 of this and 1.9 of this. You can kind of have more control and keep everybody on the same page. And in JupyterHub, you can actually use, JupyterHub is the container effectively, and you can use Notebooks or Lab as the UI, as the tool being used by your team. So what is JupyterLab? What does it do for you? Well, it lets you tell the story of your data. It lets you tell the story of how your brain and how you, as a person, as a team, have gone through solving a problem. You can do that in lots of different ways. You can do that through code. You can do that through visualizations. And you can even use Markdown to comment throughout your notes. It literally lets you blend all of that together and show that as in one place. It also provides what I call data state. So once you load data into your notebook one time, and think about if you're examining your Google Analytics logs for your website, and you're loading millions of records in from your public-facing domain. You load that data up one time, and you want to start playing around with it. After you load it, it's there. And as long as you save that instance, that variable, you can go back to it and do other mutations and do other work with it. You don't have to keep going back to the source, calling APIs, waiting a minute or two, and loading all that up. It stays around for you. It allows you to run numerous experimentations without reloading. And it gives you the ability to share with others. And not just share your code. We can all send snippets through Slack, or we can email a file, check it into a repo, and show someone your fork. But with this, if you've loaded the data and done the work and generated some charts and some graphs, and you've shown some of the code you've used to do this work, you can save all that and check it into GitHub, and then send them a link to that file within your fork. And when it renders, GitHub literally converts, the notebook is literally just JSON behind the scenes when it's on disk. But GitHub actually converts it to visual representation, and it will show your team everything you're trying to communicate with them. You're not sending code and then like a JPEG of a chart and trying to have them put it all together. It's all in one place. So what is JupyterLab? JupyterLab is the next generation of Jupyter Notebooks. It brings into the system a lot of extensions. All the core functionality that's in JupyterLab is done through a extension system. All the file menus, they brought in a terminal, so you can access your terminal. You can add a text editor. It goes actually beyond code. You can literally live within it as same way you would an IDE, and you can do git pulls and checkouts and check-ins and commits and all of those things right within your IDE and different tabs of your web browser. And they even added drag and drop support, and this really cool way you can do multi-panels. You can actually take different things you're trying to load, your CSV file and your code and the visualization, and you can show all of those in a terminal in one view and one screen. So what does JupyterLab do? I found this chart online, and I really like what it says. JupyterLab basically does a lot of these things. It does just about all of them. It's an IDE. It provides visualizations. It gives you access to a text editor. And it provides an interactive shell around your work. What it doesn't do is all of those things as well as an IDE. It is very close and has a lot of good functionality, but it is not a full IDE, and it's kind of the epitome of jack of all trades, master of none. But putting all this together in context, it gives you a really good web-based IDE around doing data exploration and other prototype work. A little bit of history. 2011, first IPython notebook ships. Then they start going into JupyterLab, 0.16, and then in 2018, they came out with the first beta. Little more than a year ago, the first beta came out, and then they had 2 more betas, and then the current latest release is 0.35. That's the current one that's out there today, if you go to try and install. And what's interesting is version 1.0 was planned for December of last year, and we're here wrapping up April, and there's still, as of right now, 60 to 75 issues to be worked down. So if you use this tool and you like it and want to keep working with it, it's a great place to go and contribute. So a quick note on the tech stack behind JupyterLab. The predominant web framework inside of JupyterLab is React. It's 90+% React. But the creators, the team building JupyterLab, they needed a little more advanced technology they could use to give that really rich IDE-like, desktop-like experience inside a web browser. So they actually built a new framework. And I know you're probably thinking, last thing we need are more frameworks, but they built one called Phosphor.js. And it's a complement to React. It is not a React competitor or another one that we want to pull into our projects. But if you have this really rich copy and paste, drag and drop functionality that they needed, it's a cool open source framework that kind of spun out of this project. Okay, so now we know more about it. How can I get it? Well, so JupyterLab is based on Python. So you're going to want to install Python first. If you're on a Mac like I am, you can use Homebrew. Conda is another cool package you can use to pull it down. And if you, on a Windows machine, the best way I've personally seen is going up to python.org and downloading the exe, just installing it locally. Then to install JupyterLab, the commands are literally right here. They're one-liners. Pip install from pip or conda install. And then that's it. You have everything installed you need. You have Python. You have JupyterLab installed through pip. You literally drop to a terminal and type in Jupyter space lab. And it just starts up a terminal, starts spinning everything up, and it launches your web browser to localhost 8888, and you're off to the races. So let's jump into JupyterLab, take a look at a couple of these things. We'll look at some of the cool drag and drop functionalities they have in a web browser. The designers did a really good job with auto-completing, debugging. There's this term called magic commands, which lets you do a little more advanced troubleshooting of some of your code. And we'll talk about how we use panels and tabs. Okay, so if I bounce back to my terminal here, that's not where I wanted to go. To this terminal. I have JupyterLab running, and I've already typed in the Jupyter space lab command, and I've had this running for a while, for days. But this is what it's kind of putting out if you're curious to your terminal. It's just telling you what it's doing. It's saving certain files, it's loading certain packages, et cetera, et cetera. It's communicating that to you through the browser. So if you're ever trying to debug something going on in Jupyter Notebooks or JupyterLab, this is a cool place to go to kind of see what kind of errors you're seeing. But I leave the terminal running in the background, and once it comes up, it loads up with this, this interface. And as a quick note, on the last slide is a link to the GitHub repo. You can find it under Ryan Bales on GitHub. All this code is up there, especially some of the cool kind of helper files. I saved my bash. If you're a Mac user or a Linux user, for that matter, I saved my my bash profile or a subset of it. And I've actually gone as far as just, I run this so often, I just came in and put little commands in. So I actually have a way to manage all my virtual environments for Python and all of the packages I have installed in them just from like one-liner commands. And I just made it so I could just type in the word lab, and it starts up a virtual environment and starts up JupyterLab, and it's ready to go. So that's all up there too if you want to use those locally. Jump right in. So one of the things you'll notice here about JupyterLab versus Jupyter Notebooks is in Jupyter Notebooks, and what frustrated me personally about it was every new notebook that I would work on, and when you're trying to do exploration or you're playing around with stuff, you have lots of ideas, right? So you might make like 5 different notebooks, 5 different files, and you're trying different things, like version 1, version 2, version 3, because you want to see which one you like at the end and hopefully throw the other ones away or save them just to recall. Jupyter Notebooks would put every single one of those notebooks in a new tab in your browser. And I got super frustrated because at the same time I was writing those notebooks, I was researching different techniques, different API documentation, different code documentation, and I just got super lost. I had notebooks all over the place, and it was literally a crapshoot to manage. So the first thing that JupyterLab did that I was really excited about is it took all those notebooks and it put them into a container down inside your browser. So in this one tab that is JupyterLab, you'll notice every single notebook I've opened up for this demo is right there across the top. And you also have some very nice, just super helpful menus. You can even add folders here. There's an add folder button. Like you can literally manage your project, like your prototype project, right here from JupyterLab. You can add folders, you can add new notebooks. When I click add, it gives me a new tab. Those are all of the different virtual environments installed locally I have. I have Python 3, I do a lot of Kagles. I even have R on here. We'll get to that in a second. And then the first tab there is notebooks. If all you want is a Python console, you can have a Python console tab come up if you don't want any visualization. And then also, really cool at the bottom there, if you want to get into a terminal and just pop to a terminal, you can pop one of those up as well. And it pops you into the terminal where you started JupyterLab from. So, over on the left here, I can literally walk through my folder structure of my project, go back to home. I find this super helpful. There's a search console. If there's a command you're trying to remember, like run cell, you can literally just start typing it, and it'll tell you all the different commands that are available inside of JupyterLabs. If you want to see all the sessions you have running, every notebook creates a new session within the JupyterLab system. So if one gets hung and you want to destroy it, you can come over here and just shut one down. So all kinds of cool help on the left. This is also sizable. So if you don't want to have it in your face, you can bring it over. If you want to get more screen real estate, you can bring it back when you want to use it. And then all kinds of different menus up here to play around with. Typical CRUD functions, edit, undo. The cool one I like to go play around with is, if you're a Darkula fan, they brought this out in JupyterLab as well. It was not available in Jupyter Notebooks. So if you'd like a nice dark IDE, this turned out really nice. I'm going to pop back to white just. I don't know about you, but whenever I play around with IDEs, I feel like I choose different themes and layouts every 3 months. I don't know. I go from light to dark. I go from different formats, different fonts. It seems to change all the time for me. Right now I'm on a white kick, if you can't tell. Okay, so now we know kind of how JupyterLab works and what's all in the application. In the notebook, I can do lots of different cool things. So in the first cell here I just put a title. That's just a markdown cell. I put a pound sign and my title, and that's rendering just as a header. Then inside of here I just put 3 stars to get a horizontal rule, just to get some nice, clean formatting in my notebooks. Up here at the top, if I wanted to change that, there are 3 different types. You can have a code cell, you can have a markdown cell, or you can have a raw cell. And a raw cell is effectively, if you just want to put text in a cell and have it render as text, it's raw. It's just going to get rendered back out whatever you typed in. I rarely use them. I'm mostly in the markdown and code side of things. When you add a new cell, it defaults to code, and you can pop it over to markdown if you want to leverage it. Another cool thing here in this first notebook is if we scroll down and I click in this cell, Jupyter also supports LaTeX formatting for functions, for any kind of scientific notation you're doing. So if you're trying to train a machine learning model and you want to put some of the math equations that you hand-coded in a function, right above there, if you want to put the LaTeX representation of that function, you can bake that right in, and Jupyter will render it in a nice, clean, readable format. So this notebook is pretty straightforward. I just put a function in here to calculate a linear equation. So I defined a function in the first cell, and depending how you want to do it, you can tell the notebook to run all cells at once. One of the cool things I like about Jupyter is that I can run each cell individually. So I make a typo or have a bug in one function, I don't have to go and rerun 20 cells up. I can just go back to that one cell and correct my mistake, and then click the little play button. You can also do Shift-Enter. That will also run a cell for you. And you'll know it completed when you get the line number effectively over on the left-hand side. Same with a normal programming language. Below the cell is considered standard out and standard error. So if you have, in a terminal window in a Python script or any kind of script you're writing, any kind of code, when you have output coming back to you, if you're telling this function to print something or if you have an error come up, it'll pop in right below. So I'll run through these. I'm importing some Python packages. In Python, I'm using a tool called matplotlib to render some data. And then here, I'm literally just telling this code to run my different levels of polynomial equations, calculate them, and then I'm drawing them out. And you can see on the last cell there, I told it to draw 5 plots. And in standard out, right below, it's just rendering my plots right below here. It's doing that because I told it to do matplotlib inline. If you're a Python user and you want to use notebooks, if you use other IDEs like PyCharm, out of the box when you run a visualization, it pops up in a new window. If you want to run them inline in notebooks, you can do it with the inline command. Okay. So we went through all of that. So remember I talked about data state. In this example, I'm loading up so I do a lot of kegels. I just downloaded a sample house pricing data kegel, a CSV. And what I really like about this is, in a couple lines of code, I can load a CSV up using pandas. Pandas is effectively just a wrapper around the list object and NumPy arrays in Python. It just gives you a little higher level extraction and abstraction in your code. It makes it easier to work with, but I use it all the time. And read CSV is one line, and then data.head is going to give you the first 5 rows of your data. So you can go from, you can check that you have the data loading properly into your environment in 3 lines of code. And the really nice thing here is that this data object is now loaded up. It's in memory, it's stored in this notebook. I can reference it anywhere else I want, and I don't have to go back and reload it, even though right now I've stopped executing my program. I've stopped executing everything, but it's still in memory, still ready for me to work with. And then because I really like pandas, I put a little call to describe in here. If you're working with data, this is super helpful. Data.describe goes through every feature of your data set, every column, and it gives you the count of those objects, the mean, standard deviations, and a bunch of other metrics, so you can get a kind of a bird's eye view statistically of how your data in that column or feature lays out. And from here, I can start visualizing my features. I can do a histogram across the entire data set. That's going to render one chart per feature and drop it right below there in standard out. If I want to dig a little deeper in this, so this data set has, like I said, housing sales data. So it has number of bedrooms, number of square footage, number of bathrooms, number of floors. It also has sales price, because the goal here is that you can load this data up and train a model to predict that houses of similar features would go for similar prices. So if I want to dig deeper into a certain feature, I can come in here and simply access the sales price feature off my data and draw it down below. And again, if I don't want to reload this, but I want to look at other features, in this case, I'm actually going to make a feature of my data. I'm creating a new variable called data.aug, and I'm setting it equal to my data object, because I don't want to mutate the original data, or else I have to go back and reload it again. So I'm making a new feature called data.aug, effectively data2. And inside of here, I'm calling the apply function and passing in a lambda. And I'm trying to get a feature called sales price per square foot. So to the lambda, I'm passing in every row of the data set. And I'm taking the sales price of that row divided by the summation of the first and second floor square footage. And what that'll do is just go through row by row and run that function, save that to a new feature. And if I scroll out, again, I do a data.head, and scroll out to the right, I have my data, my sales price per square foot. And again, I can plot it. I can do other stuff with this data, and I didn't have to go reload anything. I can just keep doing experimentation, building more features, doing more analysis, and I can keep going down this notebook, and I just keep working with that same data and not having to reload it. This was a couple thousand rows, but if you're loading a couple million rows, that's super helpful. Something else I tossed in this notebook, like I said, with my job at Dialog Tech, we do a lot of work with audio recordings. What's really handy is that with IPython.display, you can pass in different types of objects, and you can embed them in your notebook. So I can actually, I'm not going to play this here, but I can actually embed audio files and then play them on my computer. That comes in super handy if you're doing exploration of data, of audio files. I built notebooks before where you load the audio, play it, and then you can actually translate that to a spectrogram or some other set of features to leverage that information. Okay, so that's the basics. And you're probably like, right, cool, my IDE does that, and 1,000 things more. I get it. So one thing that is also nice is I have yet to see a browser-based product that helps the developer that gives you like really good IntelliSense. And I'm not saying that out there, just I haven't personally used one. But what's cool here is that I've imported pandas into this notebook, and I have now, on this object, I have tabbed autocomplete. So I can just start typing in a function I want, hit tab, and if it knows the right function, it pulls the one up I would like. Open my parens up, hit tab again, and now it's trying to help me figure out what parameters I want to pass in to the function. I didn't have to go find the documentation. I didn't have to go look up anything on a website. It just baked it all right into this object, to this cell. If you don't want to use autocomplete, or if autocomplete is not helping you enough and you would rather read documentation, JupyterLab does have a really nice doc viewer built into it for any function on any object. Core Python, a library. If you do that object.function ? You will get the doc string output. So for the concat function, it's just telling me the parameters and a brief explanation of what the object does. And it just pops it out standard out, keeps scrolling down, and gives you the information you're trying to solve for your problem. So with autocomplete, I want to debug my code. I know that when I'm in an editor, I can put Visual Studio, I can put a breakpoint on the line, I can dig deeper into my code and see where the problem is. I want to have the same tool, or as best I can, inside of this application in my browser, in JupyterLab. So inside of Jupyter, there are some plugins you can use to do debugging. The first one actually is built into Python. This is the standard Python debugger. So here I've built a function that calculates a total. And then effectively, if it's divisible by 2, it's raising an exception, telling you it's divisible by 2, and giving you an error of the trace. So if I run this, and it comes out, it gives me an error. In the very next cell, if I type in $debug and run it, I get an interactive debugger directly in my IDE, directly in my Jupyter Notebook. From here, I can run any of these functions you saw up top. I can list the current line of code I'm on. I can step up, step into, and it'll just flow through to completion. So that's cool, that's helpful. I'm a visual kind of person. So I found some other cool tools that I wanted to show you. Some of these are still beta-ish kind of quality, so your mouse may vary, but I found one called Pixie Dust, Pixie Debugger, they call it. So, don't mind me. What happened there, if you're curious, is I actually ran the debugger and didn't put a command in and moved past that cell, and it got mad at me. It got hung up on the cell. So an error came up. I didn't type anything in here, and the UI rolled up after I moved off of it, and I couldn't do anything more. It just kind of got locked up. So with all software, there are things. Okay, so I'm going to import Pixie Debugger. I'm going to run that same line of code again. And you might notice that it renders in standard out, but it's giving me the object type. So I'm actually going to use this opportunity to show you a really cool feature, is that this application, this debugger plugin, is actually not coded to work in JupyterLab. It's not built for the extension system. It doesn't render properly. There's some bugs with it. So what's nice is that I can actually come up here and launch a classic notebook instance and do the same work. So this just simply popped me into Jupyter Notebooks. And Jupyter Notebooks doesn't give you that nice one-tab feel. It gives you this list of your notebooks. I'm going to pop into this debugging one I was in. And you keep seeing there how it popped into a new tab. Super frustrating. Then I come down here, and you can see it actually can render this. So this plugin was coded well for notebooks, but I was reading their GitHub documentation just recently, and they're still working on fixing the problems with this. But what I like about this is this kind of feels more like an IDE from a debugger standpoint. It's not an inline kind of type in R to go to next and U to go up a line. It's giving you buttons to click, and it's letting you click within your code, and then you can go up and down. And over off to the right, it's giving you your variables that are loaded and different outputs, even an expression evaluator, just some really cool, super helpful things to add to your debugging experience. One more that I found is called Bird's Eye. So this one, again, I'm pip installing Bird's Eye. This one actually loads through an extension. This is kind of going back to that extension framework of JupyterLab. A lot of the built-in extensions load themselves automatically when JupyterLab starts up. If you want to load extensions, there's a function called loadext. So I'm calling loadext Bird's Eye. And this actually runs as a web server behind the scenes. It spins up a server on that certain port. So I have to hook up the port. And then in my cell, if I just do %i, EYE, it's going to run the same code, but then give me this visual representation of my function. And then here, I can click into my function. I can see what's in it. I can see what my values were. I can do a little more debugging visually than you can with standard IDEs, with web-based IDEs. You can do a lot more with standard IDEs. So that's debugging. So one more notebook, magic commands. And this is actually something, to be honest, I've been a Jupyter user for about 2 years. It wasn't until I started putting this talk together a while ago that I came across these. I had used them before, and I've seen them in demos, but I didn't know the literal plethora of them that existed. So I was super excited, and I wanted to share with everyone. So magic commands are effectively shortcuts and wrappers around things in your OS and other Jupyter functionalities. So let's look a little closer at this. So I'm going to import NumPy, and we're going to do a little benchmarking, right? So if you're trying to write some code and you're trying to dig into the timing of that function that's being run, I can literally run %time it. I'm going to run both of these at the same time. I'm just calling a uniform and a normal distribution inside of NumPy. And it's running both of those a couple of different times, trying to get like an average calculation for how long it takes to run. And 15 microseconds for random, for uniform, and for normal 42 microseconds. So both are incredibly fast. And again, you can put that around any cell you would like, and you can see that this function, I can troubleshoot. You can see how well the code you're writing performs before you take it out of your prototype notebook and bring it into your your dev stack. So that was for one function. Down below here, you can actually do that for a given cell. So these all ran super fast, but at the top of my cell, I can do %time and get that information. Again, we touched on this before. A couple things we've already talked about. When doing visualizations, if you want them to show up in line, that's super important for notebooks you're sharing, because that way you can share the viz with your notebooks and your data. Matplotlib in line. And then module reloading, loadext. In certain cases, you can use the word auto reload, and that'll keep reloading your extension. There's certain extensions that helps with. Let's say you're in your notebook and you want to play around with You want to know what's back on disk. You don't want to pop into a terminal and cd directory. You want to just know what's there where you're at right now. Well, %ll directory will just simply pipe the output to standard out in the cell, and it's just wrapping LL on your OS. So those are all handy, but when you're writing code, it's super helpful to have a variable inspector. So when you're 20 lines of code in, or in this case, Jupyter Notebook, 20 cells of code in, you can see kind of how they're performing and what they're doing, and what's in them. So I'm just going to spin up a bunch of different variables here, int, strings, lists, etc. And then we're going to play around with the who functions. So %who, as you can see there, just gives me a list or an output of all of the names of variables that are defined in this notebook currently. So if you're like trying to figure out why this one variable is coming back undefined, this might help you find it. Further, there's a function who's, that will actually format that output into a clean table and give you the variable name, type, and it'll even, in certain cases, give you the data that's inside of it. In this case, the strings and numbers are easy. The list, it gave you the count, because it can't render all of them right there. And I've also loaded NumPy, and NumPy is a module, so it's telling me my NumPy and what type it is that I've loaded into my notebook. And then who ls, if you want to get a formatted Python list back of your variables that are defined. And you can even filter these functions by type. Also pretty cool. I can do who ls list, and if I only want to get my lists that are back, it'll bring back my Clee sports teams. And again, you can do that with your numeric types. It would give back A and C and give you back all of the variables you defined as a certain type. So if you want to see every string you have defined in this notebook right now, you can run that. OK, a couple more things here. So also really cool, same thing with self-documenting your extensions for Jupyter in your libraries and functions. All of the magic commands are documented. So if you want to see a list of them, you just ls them. %ls magic gives you a list of all the functions. And there are, as you can see, quite a bit of them. And then if I scroll down, you can also I chose time it. Time it question mark is giving me the doc string and information of how that function works. So you can even get documentation of the internal commands that are wrapped as magic commands. So super helpful, cool stuff to work with when you play around with Jupyter. OK, two more things. Then movie time. Has anybody read some reviews about the movie? I've been reading some stuff like the last couple of days, and I've had friends like texting me and stuff. No spoilers. I just heard it's super awesome. That's all I'll say. Not gonna spoil it for you. I'm excited. Sorry. 20 minutes based on this clock, so we're getting there. OK. One thing I wanted to point out too. If you're not a Python developer, I know I've done all my demos in Python. I primarily work in Python, so PHP and JavaScript. JupyterLab supports over 100 different languages. I've chosen to put about 30 or so of the icons of them up here. So PHP, Ruby, even C# for any .NET folks, R. The way that's done is through that extension system. There is a kernel that can be loaded by the IPython system where you can load up the software platform you're trying to work with. By default, it loads the Python kernel. But if you have installed the R kernel, like I showed you in that notebook, I can hit that little R button in there and make an R notebook. And for any R users out there, these few commands will install the R notebook kernel for you. So if you have R installed already in RStudio, you can actually just go to any R command prompt and run these three commands to install packages. You're doing a dev install off GitHub, and you're installing the kernel spec into JupyterLab. And you have to do it this way because the R kernel is not fully supported to install inside of Jupyter. You have to kind of sideload it off of GitHub. But I'm sure that'll get fixed at some point. So one more notebook. just to prove that we can do it. And like I said, if you come in and hit plus to add a new one, click this button, I'm now in an R shell, which is kind of cool, because a lot of cases, so I know some IDEs can support multiple languages now, but in a lot of cases, if you want to bounce languages, you're going to somewhat bounce IDEs. In this case, with Jupyter, if you install the C# kernel and the Python kernel and the R kernel, you can simply just, in the same IDE, you can work with different languages. So back to our R example. I'm just loading in a library called ggplot2, loading up a data set called diamonds. It's just a data set of a couple thousand diamonds, I believe, and their different characteristics, cut, color, clarity, and other information. I'm using the head function like I did in pandas to show them to you and show their information. And then I'm just doing some price distributions, trying to see how much these diamonds are costing based on their characteristics inside my data set. And then again, similar syntax to how you would in RStudio, the help function in this line, help AES, I'm able to get help on my aesthetic mappings function inside of R. And again, that renders right the standard out and gives you all your information around that function. And the same way you can embed inline images for Python, you can do the same thing for R. This is just a scatter plot of the cut based on price, and then I did a few more based on clarity and some other things. So those are all up on the repo if you want to look a little closer at those. Let's keep rolling. Okay, one more thing, to the cloud. So everything I've done so far has been on my local machine. We're going to kind of go to the interwebs now. We're going to go to interwebs via my phone, so bear with me. We'll see how this plays out. Let's say you work in an environment where your IT team is very hypercritical about the software you install and the things you do with your laptop, with your work machine. But you want to try Jupyter out. Well, there's options for you. This also helps in cases where you may want more CPU or RAM than your machine has to offer. It's super helpful for me. I don't have a GPU. You can spin up a server with a GPU in it, and you can effectively SSH yourself into that server and have a JupyterLab running locally that's just piping commands to your remote server and running the data and all the training, all the other stuff there on the beefier hardware, which is kind of cool. I actually have a friend that is using Jupyter to do some work, and he uses a Chromebook, like a super simple, like $500 Chromebook that you can get all this stuff set up with, and it just pipes all of his work off to a remote computer. So there's some options here for you, right? There's cloud-based hardware and hosted services, and I've even locally, I built if you're a gamer and you have a GPU box at home, you can simply just dual boot Linux and set it up that way if you like. So lots of cloud options. Amazon has a bunch. Google with their Google Cloud Platform, even Azure and IBM. Let's take an example scenario from a cost standpoint. If you're working in EC2 and you want to get a P2 X large, that's not even their latest and greatest one, the P3s. It's a very good server, not super crazy power-wise. 4 CPU, 12 gigs of RAM, and it's got a Tesla K80 in it, which is a fairly beefy server card. And it runs by default the AWS Deep Learning AMI. So that will cost you about 90 cents an hour, full price. You can do a little better if you do spot instances, but all in. So last thing I'm going to show you is there are some really quick and easy ways that you can spin this up using Terraform and other services, and then port forward SSH directly to this box so you can leverage it inside of your environment. Okay, so what I've done here is I ran all this ahead of time to get all the infrastructure spun up on AWS. Let's make sure. Hey, we're still in. Cool. All right. So first things first, the code. This function, this file is a Terraform definition file, and all I'm doing is passing in Key things here are I'm passing in an AMI ID. This is the AMI ID for Amazon's Deep Learning Box. That comes pre-baked with all of the Python, CUDA, CNN, CUDNN, Keras, all the tools you're going to use in the data science world come just pre-baked on top of that. I'm looking for a P2X large. I'm passing in a security group I'm defining that gives me port 22 access. And I'm setting up an elastic IP. So I'm putting a static IP in front of this box so I can then port forward myself to it. Then you go into your terminal, you run this, Terraform build, and pass this file in, and it'll build this infrastructure for you in your AWS account, and poof, it'll be ready to go. But then you got to connect to it. So what I built out is in my SSH config, I built a couple of helpful little things. I defined AWS GPU server and AWS GPU notebook server. And all this is really doing is just, I'm telling it what hostname to go to. I'm using EC2-user, that's the standard user you use in Amazon when hooking up to a server. And I'm passing in my PEM, or my security access file, to give me access to that server. And when I'm setting it up for notebook access, I'm just adding this line here at the bottom. I'm port forwarding port 8914 locally to port 8888 on the server, and that's allowing me to run notebook here, Jupyter Notebooks here, and then port forward off to the server. And then finally, a quick little script called start lab, which just basically starts up the SSH, makes the notebooks directory, and does some other cool things. So popping back into iTerm, going back to my other tab, if I call this function, this just SSH to that server over my phone. That's awesome. I'm going to copy this token here. I'm going to cheat a little bit. So because I'm accessing the public internet, right? There's lots of ways to set up security for this. I chose to go very low tech. When I spin this up, it gives me a token. I copy it to my clipboard. And when I come back into this tab over here, localhost 8914/lab, if I can spin this back up, maybe it'll work again for me. There she goes. It didn't prompt this time, but this is actually running off a server. You can tell because there's tons more environments for Python set up there inside of Jupyter, but this is running on remote hardware, but giving me results here in my environment. I can spin up this notebook that's running on that server and do anything I want. And I am not leveraging my current hardware. I didn't have to install anything, just a couple of scripts and 90 cents an hour in AWS, and this too can work for you. Cool. So while we're in here, a couple more things I wanted to show. If that's not for you, and you don't want to do port forwarding locally, you don't want to mess around with SSH and everything else, there are other tools in Amazon and other providers to give this for you. So Amazon has a tool called SageMaker. It's a pretty well baked out machine learning based platform. You can kick off training jobs for models. You can do all kinds of hyperparameter tuning, other fun things. But what I've been using it for recently is for a notebook instance. So inside of SageMaker, you can make a notebook instance, and you're literally just telling it the server type you want, the access you want to grant to it, and everything else. And when you start things up, you can even start and down you can up and down these servers, and it keeps your state, it keeps your data, it keeps that EBS mount, that data backing it, available to you, and you can stop and start these, which is kind of handy. You can run it for a few hours, pay them a few bucks, finish the work you wanted to do, save your work, and shut down. And it's nice, too, because they actually even have embraced both Jupyter Notebooks with this Open Jupyter and Open JupyterLab to get into the full JupyterLab. And if I come back over here, this is actually running a SageMaker notebook directly off Amazon to leverage that environment. So same exact environment you saw on my local system, just, again, I'm running in a browser. I'm just paying Amazon a buck, for this case, about $1.26 an hour to leverage their remote hardware. Finally, one last technique I wanted to show. If you're a Google fan, Google came out with a tool just last year called Collaboratory. I've used this tool a little bit. It's fairly well baked out. They just added Python 3 support, I think, in the last few months. But what's cool here is that there's no hardware cost. It's effectively free, and I say that loosely because there are some settings you can change to use Google's tensor board chips, or whatever, I forget what they're called. They're tensor cards. That will cost you a little bit, but for the most part, if you're just running locally, you can running on their core offering, it just loads up and works for you for free. And all the notebooks you save, like you log in as a Google account, and when you log in as your Google account, it just, when you make a new notebook, it saves it into your drive. So it just saves them right to your drive, and it's all ready to go. So if you're a Google fan and want to try Collaboratory, that one's hosted by Google and effectively free for the most part. So lots of options on the cloud. Just back into some slides, the notes here on the hosted instance. So that same server we paid 90 cents for when we made the hardware ourselves. If you don't want to manage the Terraform code and do that information, Amazon gives you the ML version, the SageMaker version, ml.p2.xlarge. Same exact server, just some extra Amazon love around it, and they charge you 4% more. So if you don't want to go through all that, you can pay them a few more cents and leverage that. And again, you have Collaboratory as an option there as well. So in summary, JupyterLab is out. It's been out for over a year, still in beta, but hopefully it will be available in a 1.0 really soon. 100 or more languages available for you and your team, and lots of other options, cloud-based and otherwise, to work with. So go forth and build notebooks and have fun. I saw some hands go up. I'm like blinded by this light, so we have about 8 minutes left before we go break for popcorn and movie. I'm happy to stay up here, happy to take questions. Thanks for your time, and I hope you enjoyed Star Trek.